Let's go ahead and look at the 2012 question. Now you're going to notice that the 2012 question is, unfortunately, it is calculator act. It's kind of a good thing actually, but that means there's only so much we can do. So our job, to be honest with you, is going to be real nice. And it's this. Our job is to make sense of A, B, C, and talk a little bit about D, but mostly with these problems, it's just learning how to set them up, right? Just knowing what you need to do in case it pops up that's non-calculator active. So the rate at which people enter an amusement park is modeled by this function here. So this is something's coming in. The rate at which people leave the amusement park the same day is given by this. So now we know, okay, very similar to what we talked about in the past. Something's coming in, something's coming out. Both E of t and LT are measured in people per hour. Ha! That's the rate. So now we know if I write PVA, we're obviously in velocity. And these functions are valid from 9 to 23, the hours during which the park is open. At t equals 9, there are no people in the park. Okay, so we have some park, right? This is the park right here. I'm gonna write park. This is the people entering the park. So I'm gonna just draw like a little sidewalk. People that are entering the park right here. Okay, not the best drawer, but people are entering the park and then people are leaving the park, right? So very standard problem. Now there is 0 people to start off, so apparently not that popular. There's not a line. So let's go to part A. How many people have entered the park by 5 p.m.? T equals 17. Round answer to the nearest whole. How many people entered the park? Okay, we don't care about how many people left, how many people are there. We just care about how many people entered. We were given the rate at which people enter is by E of t. So if I want to find A, all I got to do is the antiderivative from 9, that's my starting value, to 17, E of t dt. That's it. I plug this into my calculator and I get my answer. Not calculator active, so we can't do this one. All right, even if we try to do this one by hand, we couldn't. That's why they're calculator actives, right? So we just need to know how to set this up. So that's part A. Part B is a little bit tough. The price of admission to the park is $15 until 5 p.m. T equals 17. After 5 p.m., the price of admission to the park is 11. How many dollars are collected from admissions to the park on that given day? So all they want to know is how much money have they made this particular day. They don't really care about how many people were started with. It was 0 anyway. And they don't care about how many people left, right? People leaving has nothing to do with how much money they made. So this is what we have to do. For every person that has entered the store, not the store, the park, from 9 to 17, the price of admission was 15. So this is what we can do. We're going to do the antiderivative from 9 to 17. That's going to tell me how much people have entered this park before 5 p.m. So we know the price of admission from the starting till 5 p.m. Okay. How many people have entered? Well, we would calculate that, and let's say I know the answer is already, because this would have been done on part A. The answer, let's say, is 6,000 people have entered. Then we're going to take the 6,000 and we're going to multiply by $15, because that's how much, $15, because that's how much it costs per person. So then we would multiply this by 15, okay? And that's going to tell me the cost. If you wanted to, you could just put let me get rid of this. You could just put the 15 right here. $15 is associated with each person that comes in here. All right, so we're gonna get this plus, well, now what happens after 5 o'clock? Well, after 5 o'clock, it is, we're gonna write 17 to 23 now, E of t dt. And how much does it cost now? The price of admission to the park is $11. So again, I could just put the $11 in the front here, because you know we're gonna have to multiply that at the very end. So it's gonna be this plus this will tell me how much actual money was collected from admissions to that park. So hopefully that makes sense. Again, the job is to understand these, not necessarily figure these out. So h of t is equal to this antiderivative. Now E of x and L of x, these are rates. So it's how much people came in minus how much people came out from 9 to 23. The value of h of 17 to the nearest whole number is 3,725. Okay, so we're going to ask, find the value of h prime of 17 and explain the meaning of h of 17 and h prime of 17. Now, here's what you need to know. H of 17, that is going to tell you exactly how many people are in the park from t equals 9 to t equals 17, we're gonna know that the value of this is, that's 3,725 people that are in the park at that moment in time. We took the antiderivative, right? We're at PVA. That's gonna get me to position. I'm taking into account that how many people went in, how many people went out. So from t equals 9 to t equals 17, the value of h of 17 in particular, so I'm gonna say h of 17 is at exactly 17 minutes. There are 3,725 people at the park currently. Let's go ahead and look at h prime of 17. We're gonna take the derivative, right? And if I take the derivative, h prime of 17, when I take the derivative, well, derivative anti-cancels out and we have to plug in the t. So we get e of t minus l of t. Well, I'm gonna just write a t here for now. Well, if I go ahead and plug in my 17 now, sorry, it's a little sloppy. I'm gonna get e of 17 minus l of 17. Now, this is rates. We're given the rates. So if I was to think about this, e of 17, this is gonna tell me the rates at which people are entering, subtracted by the rates that people are leaving. So I'm given derivative, they're telling me the rate. So if I was to write this out, the number of people in the park is decreasing by a rate of 380 people per, I believe is an hour, people per hour. Boom, okay. The number of people in the park is decreasing by a rate of 300 people per hour. I'm not gonna put the negative symbol because the word decreasing is the negative symbol. So that's how we would justify this right here. Or you can say at h prime of 17, at t equals 17, the rate that people are leaving is decreasing by 380 people per hour. As long as we have the units, that's all that matters. At what time t for 9 to 23 does the model predict the number of people in the park is a maximum? Well, this is where we're gonna do e of t minus l prime of t. And we're gonna set it equal to 0. Obviously, we're not given a calculator, but we'll set it equal to 0. Because when we do and we find this t value, we can compare it on the graph, right? What happens on the graph? On the graph, maybe it goes from positive to negative, so then it's a maximum. Or it goes from negative to positive, so it's a minimum. So being able to subtract these two, set it equal to 0, and then analyze it from left to right will tell us whether it's at a maximum or not. So hopefully you guys enjoyed. That kind of wraps up this problem here.